Hi guys, welcome back to yet another video of Overing Slayer, and today as you can see we're gonna do common logarithms and natural logarithms. Before coming across these two terms we need to be aware of two more terms, that is exponents and logarithms. What are exponents? Exponents. Exponents simply refer to a number which can be multiplied by itself any number of times. Let's take an instance, an example. 2 multiplied by itself gives us 2 to the power 2. This is the exponential form. This can also be referred to as 4, and 2 square gives us 4, as we know. Let's take another example. 2 multiplied by itself 3 times or thrice, this gives us 2 to the power 3, which gives us 8. This is also the exponential form, and this is the normal form, which eventually gives us 8. So this is what exponents are. Coming to logarithms, let's take two examples, two numbers, 4 and say 16. How are they related? Let me just rub this off. How are they related? They can be related to each other by 4 square equal to 16. So the part 2 relates 4 and 16. 4 square gives us 16, 4 into 4, that gives us 16 only. So to write it in exponential form and logarithmic form, a variable form has to be written first. Y equal to b to the power t. This is the exponential form, and for the logarithmic form, t will be equal to log base y. This is the logarithmic form, right? So here y is 16, b is 4 and t is 2. In logarithmic form, we get t is 2, right? Writing in logarithmic form, we get 2 equal to log base 416. We can confirm the same by the converse, which says y equal to b to the power t. B is 16 and b is 4, sorry, y is 16. B is 4 and t is 2. So this is logarithms. By the exact definition, what does logarithm say? Logarithm is nothing but the part to which a base must be raised to attain a particular number. The base here is 4 and the number which is being obtained is 16. So the power 2 is the main factor here, which in the end eventually gives us 4 square equal to 16. In the logarithmic form, 2 equals to log 16 to the pi base 4. So now let's jump to common logarithms. Common logarithms are generally needed in computational work. For example, let's take an example. Log base will be 10, this will be 1000. The value will be 3. So to prove this, we are gonna use this form, the exponential form as well as the logarithmic form. Y equal to b to the power t can also be written as t equal to log base y. So to prove this, here the base is 10. The base is 10, okay. B will be equal to 10. The value of y is 1000, right? And the value of t is 3. The value of t is 3, right? So we can also write it as y equal to b to the power t. So 1000 equals to b 10 to the power t. T is 3. So 10 to the power 3 is 1000. How? Because 10 multiplied by 10 multiplied by 10 gives you 1000. This is what common logarithms are. Take another example for better understanding. Log base 381 is equal to question mark. So clearly we have to find the value of t, because y equal to b to the power t, or in logarithmic form t equals to log base y. Here the base is 3, the value of y is 81 and the value of t is unknown. So writing it in this form, this is to the power of t, not bt. Writing in this form, y is 81, b is 3, 3 to the power, let's say t. So 3 to the power how much will get you to 81? So 3 square is 9, 3 to the power 3 is 27, and 27 into 3 is 81. So 3 to the power 4 gives you 81. So the value of 4 will give, the value of t will give us 4. So the answer is t equal to 4. We had to find the value of t. We come to natural logarithms. So far we have learned that common logarithms includes y equal to b to the power t, where t is equal to log base, that is b, y. This is the common logarithms. The natural logarithms has a term, has a symbol rather, that is e. Most of you know about this, e. So here b is replaced by e. So y equal to e to the power t. This can also be written as t equals to log base e y, or ln y. Right? Let's take some examples. Let's take log base e, of course, because we are doing natural logarithms, and e here to the power 7. What will be the answer to this? Here, since the base and the variable both are same irrespective of the power, the answer will come to 7 only. So to prove this, we can use this form. Here log base e y equal to t. Here t is 7, e will be e as itself is, and y is e to the power 7. Going to this form, e to the power 7 equals to e to the power t as it remains. So the symbol is same, so the answer will be t equal to 7. Okay, I can write it in a better way. T equal to 7. So this is how you prove natural logarithms. Natural logarithms are generally used in analytical form for analytical work.